The box plot below shows the speeds of cars measured by the Royal Canadian Mounted Police on certain sections of roadway over the course of a week. Speeds are given in kilometers per hour. What was the median speed measured? So the median speed is right here. So the median speed was 80 kilometers per hour. The highest and lowest were 100 kilometers per hour, and 55 was the lowest. Did most drivers go a particular speed? How do you know? So I know that 1/4 of the drivers went between 74 and 80 kilometers per hour, and half of the drivers went between 74 and 90. So half of the drivers went between 74 and 90 kilometers per hour. Can you tell how many drivers' speeds were measured that week? Nope. You can't tell from a histogram. I mean, from a, you can tell from a histogram. You cannot tell from a box plot. If the RCMP measured the speeds of 332 cars that week, how many drivers were going faster than 80 kilometers per hour? So 80 is the median. So I know that half the drivers went greater than 80. So 332 divided by 2 is 166. So 166 drivers went faster than 80 kilometers per hour. How many drove faster than 90? So Q3 is 90, so I know that 25% of the data is faster than 90. So that would be 332 divided by 4 to get 25%, which is 83. So 83 drivers went faster than 90 kilometers per hour. What is the IQR for this set of data? So the IQR is Q3 minus Q1. So it's 90 minus 74, which is 16 kilometers per hour. Can you tell if the speeds between 80 kilometers per hour and 90 kilometers per hour were closer to 80 or closer to 90? No, you can't tell. All you know is that they were in between. Those two speeds. Solve the quadratic equations below using any method. So when I look at this equation, the first thing I think of is that this is squared. So I can undo a square by taking the square root. So then I would get x minus 2 equals, and then the square root of negative 3. But here we have a problem because we can't take the square root of a negative number. So this equation has no solution. Six x squared minus x minus 2 equals 0. First I'm going to try to factor it. So 6x squared minus 2. See, this would be negative 12x squared, and then this would be negative 1x. Two numbers that multiply to negative 12 and add to negative 1 would be negative 4x and 3x. So then, let's see, I would get 3x here and 2x. 2 times negative 2 is negative 4. 3 times 1 is 3. Negative 2 times 1 is negative 2. Check. So this equals 3x minus 2 times 2x plus 1 equals 0. Now I have a product of two factors equals 0. So I can use the zero product property. 3x minus 2 equals 0. 2x plus 1 equals 0. And now I just solve each equation. And I get x equals 2/3. or x equals negative 1/2. 4x squared minus 4x minus 1. So the first thing that I'm going to do is move the 1 over to the other side. So 4x squared minus 4x plus 1 equals 0. Again, I'm going to try to factor it. So we get 4x squared and then 1. Two numbers that multiply to 4x squared and add to negative 4x would be negative 2x and negative 2x. Right? 2 times 2 is negative 4. 2 plus 2 is negative, or 2 times 2 is 4. Yeah. Negative 2x and negative 2x. So this would be 2x times 2x, negative 1 times negative 1. So I get 2x minus 1 squared equals 0. If I take the square root of both sides, then I would get 2x minus 1 equals 0. Now I can just solve it. So x equals 1/2. This is called a double root because it's a quadratic equation, but it only has one solution. All right, now we've got this big thing. I notice all of these are really big numbers, so I'm not going to try to factor it. I could use the quadratic formula, but first I'm going to see if these have a common factor. So I'm going to see if they're divisible by 3. 4 plus 2 is 6, plus 7 is 13, so that's not divisible by 3. They're not divisible by 2. They're not divisible by 5. So I'm just going to go ahead and use the quadratic formula. So x equals, let's see, A is 427, B is 731, and C is negative 280. So x equals negative b, so negative 731 plus or minus the square root of b squared. 731 squared minus 4 times a, 427, times c, negative 280, all divided by 2 times 427. So x equals negative 731 plus or minus the square root. So now I have to do 731 squared, which equals 534,361 plus all of this. I've got two negative signs, so it's going to be it's going to make a positive. 4 times 427 times 280 equals 478,240, all divided by 2 times 427 equals 854. So now negative 731 plus or minus the square root of these two numbers added together, which is 1,012,601. Okay, now we take the square root of that. Which is 1,006.3. So x equals negative 731 plus or minus 1,006.3, all divided by 854. Now we split it into two equations. X equals negative 731 plus 1,006.3 divided by 854. And x equals negative 731 minus 1,006.3, all divided by 854. So I'm just going to do that on my calculator. So 1006.3 minus 731 equals that, divided by 854. So first I got x equals 0.32. For the second one, I got x equals negative 2.03. Graph the system of inequalities below and shade its solution set. So first I'm going to graph 2x. So this is greater than or equal to, so it'll be a solid line. So minus 7, 1, 2, 3, 4, 5, 6, 7. 2/3 would be up 2 and to the right 1, 2, 3. I make a solid line because I have that equal sign. And I want all the y values that are greater than that. So I'm going to shade above. Now for this one, I want to start at 4. My slope is -1, so I go down 1 to the right 1. This is not a solid line, so I need to make it dashed because I have no equal sign there. And I want the y values that are less than this line. So that's all of these. So the solution set to this system of inequalities is the region where both are shaded, which is this region right here. So all points in this region are solutions to both of those inequalities.